Hi, my name is Matt Corliss, and I will be presenting for Group 14. We decided as a group to do chutes and ladders, so if I run the executable jar file, you at first see the main menu. So this menu has several different choices. You can play one player by yourself, two players, three, or four, or you can have three computers and one user, two computers and one or two users, and one computer with up to three users. Right now I am going to play with four users so that I can give you a better representation of how the game works. Here you will see several different things. You will see the actual board game right here. These are the four player pieces. So up here it'll say player 1 is blue, player 2 is red, player 3 is black, player 4 is green. This right here is the power meter that determines how much force this spinner will spin. And this button right here is to spin. So if we do it with full speed, you'll see that the arrow spins for quite a while. We rolled a 5, so player 1 is now on 5. If we roll for player 2, that was with about a medium speed, and we rolled a 4. So what we saw there is player 1 went to 4 and then took the ladder up and got to spot 14. Now, the animation on that is a little bit off because red kind of went this way. And that's something that we sort of struggled with. I know Alex worked on it and made the animations look a little bit better than originally. But the animations are still a little off for the ladders and especially for the slides that you will see later on. But the result is always correct. So if we roll for player 3 at really low power, you'll see that the arrow will barely spin. So it hardly spun at all. Roll to 5, it's a little close, but that's a 5. And now player 4, which is green's turn. So if we spin for him, we rolled a 1, and so it took the ladder up to spot 38. And now we're back to player 1, which is blue. So if we spin for him, we roll a 3, so 5 to 8. Now we are back to player 2's turn, and player 2 is red. So if we spin for red, we get a 3 and 14 to 17. Now black, and we get a 2, so it goes up 2. Now green, and we get a 5. So 1, 2, 3, 4, 5. And back to blue, and rolled a 6. So 1, 2, 3, 4, 5, 6. And a 6 for red as well, so 6 spots. Back to black, and a 1. So black is still a little bit behind all the other colors, but it's chutes and ladders, so he has a lot of chances to catch up later on. Green, which is in the lead with a 6, so took the slide. So we went from 43 all the way to 49 and ends up at 11. And as you saw, the animation went to 50 and then straight down. So the animation on this is especially off, but you still see the proper result. And blue rolled a 5, so it's 14 to 19. And a 1 for red. A 5 for black, so up to 13. And a 3 for 14. Doesn't go down because it's a ladder, not a slide, so properly stayed in the same location, or in 14. And 3 for blue. A 5 for red, so properly went to 29. And you will see, if you look, that each color is on a different spot of the board. You don't see why right now, but the reason why is because if all 4 or multiple ones are on the same square, this way one board piece doesn't cover another board piece. Hopefully later on we'll have 2 of them on the same board again, so I can show you why. Okay, so right now we get a 1 for black. Perfect timing. And so, as you can see right here, now neither one covers each other. Originally, we had it so that they were all directly in the middle, and that had the problem where black would be covering green right now, because whichever, like player 1 would cover any of the other ones, player 2 would cover black or green, and so on. And this way you'd never lose track where each game piece is. I will go ahead and continue to spin for several more iterations just so that we can hopefully have a game winner soon. Alright, took the slide down, went from 14 to 16 down to 6. And another thing to note is if you try to spin while it's still spinning, it doesn't actually do anything. Okay, I accidentally spun multiple times right there. But what I was trying to say is that if you hit spin while it's spinning, it will actually have zero effect on the overall spin. It won't actually let you do anything. You don't see anything pop up saying that, but if you were to look at the source code running in the console, you would see spin is in progress, and so it won't actually let you do the spin. So roll the 4. If I try doing it at full speed, then I hit spin like 3 times, but nothing actually happened. It's just the one long spin with the 6 from 11 to 17. And once again, I'm just going to go ahead and continuously spin for several iterations until we have a winner. Alright, and so red was on 76 and rolled a 4, took the ladder to 100 and won. So this led to this menu right here. Player 2 has won, play again. If you hit no, this will just close down and exit out of the game. If you hit yes, it'll bring you back to the main menu where once again you have more choices. So if I say I want to play with 2 computers right now and just 1 user, you will now see only 3 players playing, and you will have 3 pieces right here. So go ahead and spin, and you will notice after player 1, red and black take their turn immediately. The AI is a little impatient, but this way the games go a little quicker. And let's say for instance you are playing by yourself, but you decide, oh, I have another friend coming over, let's start a new game. You can always just hit new game, and you can do 2 users and 2 computers. And now you have 4 players and 4 game pieces once again, and you can keep playing. And maybe that player left, but now you want to do 3 computers and 1 player, and now it's just 1 user, and then the 3 computers will all take their turn immediately after yours. So if you see, they kind of just are a little impatient, but it is what it is. And so the game will go by much quicker this way. And if I go ahead and skip ahead again, alright, and I will continue to spin until we have a winner. Alright, so blue will win on the next turn. So we will see right now that blue won, rolled a 4, so it technically would go off the map, but it just stops right there. And we have the choice again, yes, no. If we hit no, the game will close. Now if I drag the source code over onto the screen right there, I will start to show you the different folders we have. So we have the images, which is the arrow icon, the game board, and the small spinner. And then we have the actual Java files. I'll go ahead and start with arrow. And arrow mostly deals with what the actual spinner is spun onto. So it finds the degrees in order to calculate what value of spin it was. Board data deals with the different cases where if it goes onto a slide or a ladder, when you want to do each case. Game manager deals with how many players will be on the game, and also restart. So anytime you do a new game or you complete a game and want to play again, this game manager deals with that. Game object will deal with the objects on the board. And then game screen is what actually updates the different items on the screen. So you see the 4 different players. If I go ahead and scroll down, you will see update items. And this is what's being constantly updated. The power bar, the arrow, the spin button, the new game button, the show player turn, and then these are the J labels that show what each player is. So blue would be player 1 is blue. And you also notice that these ones have this .get width and this .get height. That is so that when you change the size of the game, the new game buttons, spin buttons, etc. all adjust with it rather than being in a standard location. Whereas these are in a standard location. If I look at main menu, the main menu is similar to game screen, but this is the one that deals with when you want to choose how many players and how many computer players you want. So it has all of those different buttons for that. Move guide determines the different destinations when you're doing the different cases. And player deals with the different players. And so this is our video for group 14. I guess I can open back the game real quick and show you what I meant earlier when if you move this screen, you'll notice that these stay right there, whereas these stay in relation to the actual size of the screen. We sort of did this on purpose because if you had these moved with relation, they would either be way over here or they go onto the board when you shorten it. Whereas the spinners seem like it's much better if you put it in relation to the size of the screen. And that's all we have. So that completes our presentation. Thank you for listening.